Hello everyone, I'm Shenyang Huang from National Cheng Kung University, Taiwan. I will present searching by generating flexible and efficient one-shot NAS with architecture generator. Neural architecture search aims at searching the best architectures for various hardware constraints automatically. There are three major components in NAS: search space, search strategy, and performance estimation. Given a search space, the search strategy sample an architecture, and then an evaluator estimates its performance and updates the search strategy. The process keeps going until we find the best architecture. Currently, one-shot NAS improve efficiency. The concept of one-shot NAS is that we encode the entire search space into a new architecture called SuperNet. In the SuperNet, all candidate blocks are constructed layer by layer. By activating different blocks in different layers, the SuperNet can represent all architectures. One type of one-shot NAS is differentiable NAS. To search the architecture by gradient descent, differentiable NAS utilize a set of differentiable parameters, called architecture parameters, to indicate the architecture distribution. After finding the architecture parameters, we can directly sample the best architecture based on the parameters. However, the architecture parameters are only suitable to one specific hardware constraint. For n different hardware constraints, the training process for finding architecture parameters and the SuperNet should be conducted n time. So, the motivation of our work is that can we generate the best architecture parameters directly for various hardware constraints instead of training architecture parameters case by case? We propose the architecture generator to generate the best architecture parameters directly. After training the architecture generator, given various hardware constraints as input, the architecture generator can generate the architecture parameters directly. Therefore, only one training is required for various hardware constraints. Another issue is, usually a SuperNet is constructed by blocks of various configurations in each layer, which make the number of parameters increase exponentially. In our work, we propose the concept of unified SuperNet. In a unified SuperNet, only one type of block called unified block is constructed in each layer to reduce GPU memory consumption. In a unified block, we adopt the inverted residual bottleneck in the mobile NAND V2 as the basic block, which has one pointwise convolution, depth-wise convolution, and the other pointwise convolution. In a unified block, instead of constructing the depth-wise convolution, we construct several subblocks. In each subblocks, multiple operations can be implemented. For example, 3x3 depth-wise convolution, 5x5, 7x7, and skip connection. With the subblocks, we can approximate the entire search space by only one unified block easily. For example, if all subblocks are not implemented by skip connection, we can simulate the configurations with expansion rate 6. If two subblocks are implemented by skip connection, we can simulate the configurations with expansion rate 4. Overall, we propose the architecture generator and the unified SuperNet to improve searching efficiency and flexibility of one-shot NAS. The entire framework is called Searching by Generating NAS, SGNAS. In the experiment, we first evaluate the architecture generator on ImageNet and compare with baseline search strategy, random search, and evolution algorithm. The old search strategy utilized the same pre-trained unified SuperNet with around 320 million flops. This table shows that proposed SGNAS can achieve the highest top-1 accuracy. More importantly, even for n different hardware constraints, the architecture generator only requires 5 GPU hours totally. In this experiment, we compare SGNAS with SOTAS on ImageNet. We search the architectures under 275 million, 320 million, and 365 million flops respectively. Note that once we train the architecture generator, we can directly generate the three architectures at the same time. With similar top-1 accuracy, SGNAS need much less search time for various hardware constraints. We also compare SGNAS with SOTAS on the NAS Bench 201 benchmark. As can be seen, SGNAS can achieve reliable performance on 3 different datasets. Besides, the total search time for SGNAS is much less than other methods. In conclusion, in the proposed searching by generating NAS, SGNAS, we propose the architecture generator, which can generate the best architecture parameters directly and support various hardware constraints at the same time. We also propose unified SuperNet, a novel SuperNet structure to reduce GPU memory consumption and further improve the searching efficiency of the architecture generator. At the end, our code base is available on GitHub. Thanks for listening.